So today I want to quickly take you through a few more features of beads. The clock, trigger, and the music, 3 examples, lesson 5, 6, and 7. So here's the clock example. It's quite simple. We set up an envelope called interval envelope with the value 1000. Then we change that value to 600, then to 1000, and 400, then to 1000. That controls the interval between clicks for the clock, between ticks usually. Now you can set the clock to tick every tick by saying set click true. Let's have a listen. You can hear it's getting faster because we're changing from 1000 to 600. And that interval is shorter, so it's faster. Then we're slowing down to 1000 again, then speeding up and then slowing down. So a clock can be used to trigger other events with very good accuracy. So it's better than setting delays or anything like that between things. We can actually be quite accurate with a clock. So that's the clock. It's got an envelope there. You can also set it up with just a value if you don't want to change the speed. But we've got an envelope and we can look at the time this way. We can change the time between ticks this way. You could also look at a clock's number of beats and use that to work out whether it is an odd beat or an even beat, or 1 beat in every 4 or something like that. But we'll go into that later on. So the second thing I want to show you is trigger. This is a feature where you can set things to trigger sometime in the future. Here we have a master gain, then we have a simple sine tone and a square tone. And we're adding those as inputs to the gain 1 and gain 2. Then those gain 1 and gain 2 are going into the master gain. Now here's the important part. The frequency envelope that we set up here for the sine tone, that's changing its frequency over 5 seconds, and at the end of that we're going to set up a kill trigger that kills gain 2 and everything above it. So gain 2 was the square wave, so that's going to get stopped, essentially, when the sine tone gets to 500. So let's have a listen. Okay, so you could hear as the sine tone went up to the top, once it hit the top, the kill trigger kicked in and killed the square wave off. So kill triggers can be used to kill other sets of sound producing things. You can also use them inside your own, inside a single sound processing change to kill the sound when it's not needed anymore. The other thing you can do with with triggers of any type is to have them trigger on-the-fly beads. So here's a little bit of code. When the message received, message is received that it's to be triggered, this code here runs. So when we added that segment that said go down back to 0 over 1 second, right at the end, this code here was triggered to run. Okay, last one today is a bit more complicated, and it's worth really working through this to understand it. We have a musical system, and here we have a clock with 700 milliseconds between ticks. So here you can change the speed of the music if you wish. And we have a bead that checks against a few different things. So if it's on the beat, we do this. If we get the count of the clock, and that'll be a number that goes from 1, 2, 3, 4, 5, and we do mod 4, this percentage sign means mod, and 4 is there, so we divide the number by 4 and then get the remainder. And if the remainder is 0, that means it's divisible by 4. Then we do this. And if it's divisible by 8, we do this. Now, what are these things? Well, the first one here, it says if random 1 is less than 0.9, so that's pretty common. It's going to usually be below, if we choose a value between 0 and 1, it's 90% of the time it's going to be below 0.9. Then we choose a pitch by setting up a random number and forcing it to the Dorian scale. So this is an array of values, and we're taking a random number from 1 to 12, and we're forcing it to that scale, and we're getting a pitch. Here we're turning that pitch into a from a MIDI note into a frequency. So we're taking that pitch, it's between 0 and 12, we're adding a value so it's not right at the bottom of the keyboard. We're multiplying this by a value times between 5 and a random value between 0 and 5 times 12. So that's going to be about 60, between 0 and 60. So it's going to be a value between 32 and 92 or thereabouts. And we're adding that pitch we added before. So that's going to give us sounds moving across a wide range. Then we're creating a sine tone, a gain, and pushing it out. You also have an envelope there with different lengths, random 200, and an envelope with a long length going back down to 0 with a kill trigger to kill this off so it doesn't keep on building up. So this is going to happen most of the time. We can listen to what that sounds like by getting rid of the others. Let's get rid of the others for the moment. Have a listen. So it's obviously just one small part of the system. Now if c.getCount divided by 4 equals 0, then we do this one. Now this is a square wave. We're doing the same thing, but it's only at 20% of the time. So let's have a listen to this one. I'll get rid of these. And this one. So that's a kind of bouncy tone. It's a square wave. And the final one is this noise. Let's have a listen to that one. So it's kind of like a hi-hat. So altogether, this is what it sounds like. So no specific melody has been set up, but each of these parts work together to give a musical texture to the sound. So each of them do different things, each of them have different types of sounds, different envelopes. They all have kill triggers to kill themselves. You see the panoply there. And they also happen at different times because of these parts here. This is the clock.getCount, clock.getCount, and clock is beat. All right, thanks very much.